Okay, next we're going to look at principle of moments. So earlier we have talked about moment, that is defined as the force times the perpendicular distance from the line of action of the force to the pivot, or to the point where it is taken as a point of moment. Alright, then after that we look at the torque. So torque is defined as one of the force times the perpendicular distance between the two forces. And from the quiz I can see that some of you are a bit confused between the moment and the torque, so it has to be defined slightly differently, but actually they have the same unit and they are both about the turning effect. Okay, so regarding this moment, there's a principle, as in when it is used to solve things that are at equilibrium or have a rotation. So there's a principle behind them. Okay, so for an object that is balanced and not rotating, rotational equilibrium, then the principle is that the sum of the anti-clockwise moment must be equal to the sum of the clockwise moment. So, and you have already making use of it when you solve the previous problems. Okay, so there's one more addition to this idea, or to this equation that you used before, that is that you can actually take the point of moment at anywhere along this let's say this rod here. So for the first case, if you take the point of moment at here, then the anti-clockwise moment, which is described here, will be equal to the sum of the clockwise moment, okay, including the weight of the rod if it has one, and this is uniform, so that will be the weight here. So this also contribute to the clockwise moment. Okay, so other than that, you can actually take different points. So let's say this is point choice 1. You can also pick other choice. Let's say this is choice 2. So choice 2 can be also used to solve this rotational equilibrium problem, because as we can see here, there's a string. String means that it should provide a force tension. If we know the weight and the uh, the mass or the weight of this thing here, this block here, then we should be able to find the tension. So taking the point of moment at point 2, the anti-clockwise moment is caused by the tension. So again, you can use a pencil or a rod or a small stick to identify the direction of the rotation. So tension in this case actually is pushing this thing up or pulling this thing up, whereas the weight of the rod and also the thing that's hanging on the other side will be causing the opposite direction of the rotation. So which means that these two moment, they should be equal if this thing is not rotating. Okay, you can also take point 3, which is here. Then it'll change slightly, because instead of holding here, now you have to change your point of moment here. And the same principle still apply, as in you can use the moment caused by the mass hanging here, the weight that is pushing it down or pulling it down, must be the sum of the two moments must be equal to the moment caused by the tension this way. Okay, so let's look at the word form of this principle after you understand what I say. For an object to be in rotational equilibrium, the sum of anti-clockwise moment at any point, that's what I'm trying to highlight just now, is equal to the sum of clockwise moments at the same point. Okay, so any point that you pick, the clockwise and the anti-clockwise moment must be equal if the object is at equilibrium. You can just pick any point other than the 3 points that I mentioned just now. Any point along the rod that you can take. Is just things that is changing is the distance from this point of moment. Okay, so we move on to some example. the first case here, this will be a bit straightforward. Okay, calculate distance from the pivot that Abu should sit in order to keep the seesaw horizontally balanced. So this case is a bit simple, that we only have three forces here. One is that the force that is acting on the seesaw. So one is the weight of this girl. The weight of it is 300 Newton. One is the weight of Abu is 400 Newton. The other one is the weight of the plank. Okay, no, actually there's the forces. The Ford's force, which is the reaction force, normal reaction force, R, that is acted on by the pivot here on the plank. Okay, so this is an upward force, and the weight of the plank is downward force. Okay, so if we were to find the distance that Abu should sit, of course the point of moment that we should pick is this point here. Okay, because we don't need the R and the W anyway. So we have 300 times 4 meter. That's the rotational in the anti-clockwise direction. Should give us 400 times the distance question mark. That's the one that we're looking for. So very straightforward. You just one unknown here. So question mark will be equals to 300 times 4 divided by 400. So you get 3. Alright, let's move on to the next one. That's what I'm trying to say just now. So one direction is the 300 times 4, the other direction is 400 times the question mark. Okay, second case, we have the weight of, calculate the weight of Abu if the seesaw is horizontally balanced. You should never do that to your friend anyway. Okay, so this same case here, that we have the support reaction force, the weight. So we're not going to use this because we have the other unknown that we need to find, which is the question mark, the weight of Abu. Therefore, same thing again. So we have clockwise moment 500 times 2, and the anti-clockwise, which is question mark times 4. So again, if you find it hard to decide the direction of rotation, use a stick to represent the case described in the question. Then you use the finger to hold at the point that you want to take as the point of the moment. Alright, then you can figure out. Right, next question, I will leave it as your work. So you need to solve this. Okay, there are two parts of the question there. And I will go on to the next one. Next one in your, hold on, next one in your, next one on your handout, which is this. Okay, a non-uniform rod of unknown weight is suspended by two strings as shown in the diagram below. So this is a non-uniform rod. So be careful with this word. Non-uniform means that the weight will not act, the center of gravity will not act in the middle of this rod, like the case of the meter rule that we used in practical that day. We say that the weight is acting in the middle because we assume that the wooden piece of the meter rule is uniform and it should be in the middle. Okay, but when the question says non-uniform, we should now notice that it is not in the middle. It shouldn't be in the middle because the distribution of the mass is have more on one side and less on the other side probably. Okay, so tension on one of the string is 5 Newton. It's labeled here 5 Newton. It's 10 cm from the W. This is basically the CG, center of gravity, not in the middle. And you are asked to find the tension in the other string. That's the question mark here. Okay, so obviously we are going to take the point of moment at this center of gravity, because we don't want the second unknown, which is the weight. Okay, if we take the center of gravity at this point here, then this point shouldn't cause the weight shouldn't cause any rotational effect, because it passed through the point. So no perpendicular distance earlier that we have mentioned, so no perpendicular distance. All right, so then now is to identify which causes the moment and the moment in the opposite direction. So T, of course, T is going to be this way, and 5 Newton going to be this way, so they are opposite. So we form the solution T times 20. You can change to meter, but because both sides has the same unit of the length, so it's not necessary actually. So 5 times the 10, then you get the T. 5 times 10 divided by 20, so you get 2.5 Newton. Alright, we'll stop here for this. Then you do the question earlier and send to me.